Good morning everyone, welcome to another session of structural analysis. So in the previous class we have taken up moment distribution method, the introduction of moment distribution method. Then along with that we have taken one simple problem on that particular method. Now we will see a few more problems on moment distribution method. Okay. So note down the problem. The question is, analyze the continuous beam shown in figure using moment distribution method. And always remember, moment distribution method is also known as Hardy cross method. Hardy cross method. C. Hardy cross method. Okay. Now take down the beam. The beam is given as a continuous beam. It is fixed at this support and we have a simply support over here at this location. So this is 8 meter and this one is 12 meter and this one is 3i and this one is 2i. Okay. So this is the continuous beam given in the question. So now we have to solve this, analyze this beam using moment distribution method, and the loads on the beam is given as the load is 6 kilonewton per meter and we have a point load at a distance of 8 meters from fixed support of magnitude 9 kilonewton. Okay. So we have to calculate all these values. Okay. So I will, before solving the problem, I will name this beam. Okay. Let this be A, B and C. So the very first step in moment distribution method and slope deflection method, the very first step is to calculate fixed end moments. So how will you calculate fixed end moments? Fixed end moment is nothing but MF AB. MF AB is equal to how much? Tell me. We have a UDL over the entire span of span AB. So what will happen? Minus WL square by 12. So minus, what is the value of W there? 6 into L is how much? 8 square divided by 12. You get the value. Minus 32 kilonewton meter, not per meter, kilonewton meter. AB will be same, that is plus WL square by 12 plus 6 into 8 square divided by 12, which is equal to plus 32 kilonewton meter. Okay. Next will be MF BC. MF BC, in case of span BC, the load is eccentric load. The load is not exactly at the center. It is somewhere 8 meters from left support. So what will be this distance? 4 meters, isn't it? So MFBC is given as minus WA B square by L square. So minus W, what is the value of W there? 9 into A is 4 into 8 square divided by L square, that is 12 square. Tell me the value. Minus 16 kilonewton meter. Now what about MF CB plus WA square B by L square now. So plus 9 into 4 square into 8 divided by 12 square. 8 plus 8 kilonewton meter. Okay, so now I have calculated all the fixed end moments for this beam. That is, we have AB, BA, BC and CB. All the fixed end moments are calculated. So after calculation of fixed end moments, the next step in case of moment distribution method is to calculate distribution factor. What is the next step? Distribution factor. How to calculate distribution factor? We have a table for that. Okay, that is joint, then member, then stiffness, then total relative stiffness, then we have distribution factor. Okay, so copy down this one. So after this one, we'll go for the distribution factor. Okay, so next side heading is distribution factor. So how to calculate distribution factor? So for the calculation of distribution factor, we should go for a table, that is joint, then member, then stiffness or relative stiffness also I can say. Okay, next we have total relative stiffness. TR is stands for total relative stiffness, total relative stiffness, then distribution factor. We denote relative stiffness by K. This one has sigma K and distribution factor is K by sigma K. Alright, able to understand? So how many joints we have in this beam now? One joint. Joint is nothing but the point at which two members gets connected, two or more members. Okay, so sometimes what will happen, we will be having a column here. Okay, so two or more members. So at point B we have two members getting connected, so that is why point B is the joint. Okay, B is joint. How many members? See there, we have one member which is BA, another member is BC. So I will write here BA, BC. Now carefully, many people will get confused here. See here, see B to A. B to A, if you see at A, we have a simply support. What is the support there? Simply support. So whenever the far end is simply support, then relative stiffness is given by 3I by 4L. What is that? 3I by 4L. When we see from B to A, see there, we have BA, member B to A. B to A, I have simply support. So whenever there is simply support, then relative stiffness is given as 3I by 4L. Okay. Now when you see B to C, here it is fixed. So that will be I by L. That will be I by L. Okay. So here for BC, relative stiffness will be I by L. So now you tell me 3. What is the value of I for span BA? 2I. 2I by 4. What is the value of L there? Into 8. So 3 2s are 6 by 32. How much? 0.187 I. Okay. Next, what about this one? BC. It is 3I by 12. How much? 0.25 I. Now what is this sigma k? What do you mean by sigma k? Add these two values. 0.187 divided by 0.25. How much?
Adding this.
Yes, sigma k. 0.437 I. Okay. Now what do you mean by distribution factor? K by sigma k. So that is 0.187 divided by 0.437. How much? Tell me the value. 0.187 divided by 0.437. 0.427. I and I will get cancelled. So you will left over with only one value. The I, you will not have any I there. Now 0.25 divided by 0.572. So once you add these two values, you should get 1, at least approximately 1. What is the value you are getting? 0.9. 999 is nothing but 1 only. Okay. So able to understand here why I have taken 3I by 4L and why I have taken I by L over here. Things will get more confusing once we get few more spans. Okay. So this is just a basic problem. So make sure you do not have any doubts in this session. That is, relative stiffness is given as 3I by 4L for span BA, whereas relative stiffness is given as I by L for span BC. Okay. Until here, I hope we don't have any doubts. So we got the values of distribution factors. Now after calculation of distribution factor, we will move for moment distribution table directly. Okay. Copy down this one. Now we will go for the moment distribution table. So before going to that, what I will do, I will draw the beam itself. Okay. Very carefully you have to observe here. It seems to be easy, but once you move further, it will create confusion. See here, I will draw the beam here. I will write the table as moment distribution table, okay, as side heading. Okay. And see here, I am drawing the beam. We have one support here, which is point B, right? This is one support and this is another support we have. So I will project this one also, and this one. Okay, this is our moment distribution table. Okay, so this is point A, this is point B and point C. So before going to that, what I will do, I will before going to the further calculation, will note down the distribution factors for this joint. Okay, what is the distribution factor for point BA? 0.427, isn't it? Next value is 0.572. Okay, this is the distribution factor I am writing here. Distribution factor. Okay, after writing your distribution factor, we will write our fixed end moments, isn't it? What are the fixed end moments we have for AB, BA, BC and CB? This one is minus 32. This one plus 32. Then minus 16 and plus 8, isn't it? So these are my fixed end moments. Okay. So before solving the problem, see there, the beam is simply support at this point. Okay. Whenever you have a free support or simply support at the extreme corner of the beam. In case of moment distribution method, whenever you have simply support on the extreme corner of the beam, then what you have to do, see here, what will happen? At this point, moment will be 0. Moment will be 0. Final answer will be 0, isn't it? So what I will do, I will make this moment as 0 here itself. Whenever you get simply support at the extreme corner of the beam, you have to make that particular moment 0. So how to make that 0? See here, I have here minus 32 plus 32 minus 16 and 8 over there. So here it is fixed, no need to make any changes. But here, since we have simply support, so what I will do here, I will write here plus 32, okay. So at the same time, I have added some moment over here, okay. So 50% of that moment, that is how much? 32 by 2 is 14, 16 I will add to the neighboring support, okay. So what will happen here? This will be 0, no need to make any changes over here. Here also no need to make any changes. Now you add these values, will become, you got 0 over here, then 32 plus 16 is how much? 48, then here it is minus 16, here 8. So at this particular left side, I have simply support. So since there will be no moment at simply support, what we will do? We'll make it as 0. If it is plus 32, minus. If it is plus 100 or minus 100, plus or minus 100. Okay. At any cost, you have to make moment at the free end or at the extreme corner, that is completely 0. Okay. So now, after completing this one, now we can balance. See here, I have got 0 here. Now you balance this one. How to balance? Yes, add these two values. 48 minus 16, how much? 48 minus 16 is how much? 32. So what I will do? I will take minus 32. I will take minus 32 and multiply with this distribution factor. Tell me the value.
Minus 13.664.
Minus 13.664. Then again the same value, minus 32 into 0.572.
Minus 18.302.
Minus 304. So what we have done here in this particular step, we have balanced, isn't it? We have balanced these moments. So I'll write here, we have balanced. So do we need any balancing over here? No need of balancing here. No need of balancing over here. As soon as you balance, what we do? We go for carry over moment. Okay. So carry over moment is nothing but we'll shift this value here and we'll shift this value here, isn't it? So since we have a simply support over here, since we have simply support at the extreme corner of the beam, so that particular support will not take any moment because ultimately the moment will be 0. It will give moment but it will not take moment. Okay. Simply support will share its moment but it will not take any moment. Okay. Able to understand? So simply support is very good, isn't it? It will not take any loads but it will share the loads. Okay. So shall I send this value here? Shall I send this value here? No. But it will share this value. That is, here it is 0. What about this point? Since we have simply fixed support, so what it will do? They will share 0. 18.304 divided by 2 is how much? 9.15. So this step is said to be your carry over moment. Okay. So here it will be 0. So what is the thing here? You got 0 and 0 here, right? So do you need any balancing over here? No need of balancing. So directly calculate. Here you got 0. Add these values. Now from where you will add these values, you should add from this point. 48, don't add from top, okay, add from here. 48 minus 13.664, how much? 34.33. And what about this one? This also I think 34.3. 34 minus 34.304. This one 8 minus 9.15 minus 1.15. So these are our final moments. This is capital MAB. This is capital MBA. This one is capital MBC and capital MCB. Able to understand? So I'll do one thing. I'll take down once again what are the things we have done in this problem. Okay. So first I have drawn the beam. Okay. After that we have taken out our distribution factors. Distribution factor for BA is 0.47427 and distribution factor for BC is 0.572. Okay. After writing your distribution factors, we'll write our fixed end moments. What are the fixed end moments we got for AB? MFAB. This is MFBA, MFBC and MFCB. So once you have simply support on the extreme corner of the beam, at that particular point we have to make that moment as 0. We have to make that moment as 0. I am repeating again and again. We have to make this as 0. No need of making that as 0. Okay. Whenever we have simply support, make it as 0. How to make it 0? Add or subtract whatever the value you have. Minus 32 we have. So plus 32. Along with that, you have to transfer 50% or share the 50% of that added moment to the neighboring support. That's it. No need to add again on that side. Okay, that is why we have drawn our table in such a way that all the moments which are there in this section should be shared each other. No need to transfer this moment on that particular end. Okay, so plus 32 I have made it as 32, share it with 50%, 16. Then you add once again. Okay, so what will happen? From 0, 48, 16, all these values you got. Okay, now since we have these values are not same, these values again, this should be 0, isn't it? The moment the addition of these two moments should be 0 because we have simply support over there. Okay, so 48 minus 16 we got it as 32. Change the sign of 32 and multiply with the respective distribution factors. You multiply with that, you will get these values. Okay, so after writing these values, after balancing, you need to go for the carryover moment. So 13.664 cannot transfer to the neighboring support because it is the extreme corner. However, we can transfer to this simply support because it is not the extreme corner of the beam. Okay, so we have taken 0 from the simply support and we have not given any moment to that. Okay, similarly all these values. Understood? The main thing is you have to add from here. Many students will add 32 plus 16 plus 48 minus 13.664. So this will go wrong. So you have to add from here especially. Okay, and let us take how we got this value. How we got this 9.15? 18.3, 50% of this one. How we got 18.304? 48 minus 16 minus 32, 0.572, you got this value. Able to understand? So at any point if you got any doubt, you should be clear that how we got this 13.664? Go to the previous step. 48 minus 16 minus 32 respective moment distribution factor, you got this one. Okay, how we got this 8? We got like this. Okay, how we got 16? How we got 0 here? We got 0 because this is the step at which we have made the neighboring the extreme corner as 0. Able to understand? Any doubts still here? No. So capital MAB, BA, all the values we got. So if you add these two terms, we will get almost 0 only. Okay, 13.30 or 13.33, almost one and the same. Okay, so this is how we go for the moment distribution method when we have simply support on the extreme corner of the beam. Okay, now shear force and bending moment diagram. we can draw it very easily. So now we'll move to the next problem. Okay, copy down.